right, folks, and welcome to this week's webinar on building a no-code chatbot with your own data and ChatGPT. And all right, slightly biased, but I think this will be our coolest webinar ever. So buckle up. I think this is a very interesting webinar. So I'm Gordon Jones. I'm the COO of Decisions, and with me is my partner in crime, Derek Hippa. Hey, Derek.
Thanks, Gordon. Hey, all.
And Derek leads our RevOps team here at Decisions. A few plugs before we get started. We have a deep dive training, a 3-day training event coming up in November, the 14th through 16th. That'll be in Dallas. If you go to decisions.com/events, you can sign up there. So highly encourage you if you want to learn about decisions, if you want to pick up some tips and tricks, attend one of those trainings. We also have a couple more webinars coming up. One later this month follows a similar path to this webinar with a different technical twist. And this is building an RFP chatbot with AI using old RFPs. For us here at Decisions, we fill out a lot of these. We've probably done 100 or more. And this one is pretty cool, and it dramatically reduces the time and effort to fill out an RFP, fill out a security questionnaire, things like that. Then next month, we're going to craft a chat bot that takes our employee manuals and turns them into a bot that you can interact with, ask questions related to the employee manual or benefits, employee benefits, things like that. So those are the next two coming up. And in case you missed it, we have some previous webinars all available on our website in the video section. So we did a website on document extraction, which was basically invoice automation. We did one on taking data from our Zoom meetings and turning that into some questions and answers and summarizations. We did a webinar on data cleanup and automating and master the merge, how our merge text editor helps with prompts. So anyway, all of this you can find on our decisions.com/videos, or if you go to the homepage and dig around, you'll find it all. We also have a white paper that is very interesting. I'd point you all to that on our website. We talk a lot in there, and it's pretty interesting, and will help you on your AI journey. So if you have any questions throughout, just plug them into the Q&A or the chat. We'll for sure get to them at the end. We might get to them in the middle. So please ask away. Again, this is a really cool topic. So what are we going to do here in the next 45 minutes or so? I'm going to do a very brief introduction to Decisions. We're a no-code business process automation platform that basically helps anybody build complex software quickly. And then we're going to dive a little bit of background into generative AI, delivering value, and how some of these webinars that we've done will really allow you to present some quick wins to the company. Then a little background into vectors and embeddings. How does this all work? Because it plays into what Derek is going to show you all. And that's how we built a chatbot to extract data from our Salesforce system around use cases within Decisions, what our customers are using us for. We have literally about 1,400 use cases defined within Salesforce. And he's going to show you how we can make it easier to search those. So, all right, I'll go ahead and get started. I've only got like 3 or 4 slides here as an overview of Decisions. So what is Decisions? We're a no-code business process automation platform that helps companies build complex software quickly. There's 3 use cases common to Decisions. The first is rule engine and decisioning. The whole idea here is to take complex business logic, so think medical claims, think insurance underwriting rules, think loan origination rules, and take those rules, and instead of having them in stored procedures or custom code, we put them into a graphical rule-based interface that's easy for your end users, for your business experts to edit, maintain, if not build themselves. We have a number of clients doing big time things with rules. For example, Roche Genentech, the city of New York, among others. Another common use case is to extend and expand these the big bricks. So SAP, Salesforce, NetSuite, think Epic or Cerner if you're in the healthcare industry. But it's to sit off to the side and handle special processes, customer-specific pricing, customer-specific packaging, rules, requirements. So it's to manage complexity such that you don't have to custom code your your big bricks. I've had clients tell us, look, I've got the big stuff covered, and we kind of live between the cracks or sit off to the side of these big software packages. Third use case is, I'd call it general purpose workflow and orchestration. So it's sitting between and amongst software applications. The example that we're going to show you shortly is talking back and forth to ChatGPT, and then engaging end users when necessary in this workflow. So we have some clients with upwards of 45 different little automations that they've built to automate business processes. And if you want to, Derek is going to show us some examples here shortly, but this is probably the most common use case that we have, is orchestrating business processes between and amongst various software applications. To learn more, I would highly encourage you to sign up on our website for a demo. One of our sales engineers would love to spend an hour with you walking through the tool, showing you how to build things. You can ask all kinds of questions. So you can sign up right on our website. And by all means, go there, get the white paper, and attend one of our events. All right, the plugs are over, and now it's time to dive right in. So the first thing I'll point out is that, okay, right now, Gartner has said that generative AI is basically at the top of the hype curve. So what that means is, everybody's hearing about it, everybody's trying it, but you're also starting to hear a lot of negative stuff. Oh, people use it and it doesn't quite work. But it's kind of a good thing, and I think you'll see in the examples that we show you that from a productivity standpoint, the things that Derek's going to show and that have built, there's an awful lot of value to be extracted from this technology. And I think what you hear about in the news is a lot on hallucinations and when the AI gets it wrong. But what I'm going to show you here in a minute is that if you really narrow the tasks down, if you work the prompts, and if you structure it right, it can get it right nearly 100% of the time and really help automate processes that weren't possible in the past. So, generative AI has a lot of long-term potential in a lot of areas around, coding and product development and creating new businesses and business models. But what we're going to focus on here is this middle section. So cost and productivity opportunities that you all can deliver very quickly that bring value to the business. So worker augmentation, talent optimization, and process improvement. And what have we learned so far? We've internally, we've built a lot of things over the last several months. And I just want to share some of the learnings in terms of orchestrating and automating. If you narrow the task down, these models do a great job of getting it right when you keep it simple or keep the ask pretty small. For example, if you send a bunch of data to ChatGPT and then ask it 10 questions, 50% of the time you might get answers to 10, but sometimes it times out, or sometimes it gives you 1 through 4. But if you keep it small and then maybe make multiple calls where you build on that, we've seen that it works extremely well, and the accuracy and the completion go way up. Another thing that Decisions is great for is auditing and validating. What was sent, because we can keep track of what was sent, what was received. We can validate the data that's sent, so you can run it against rules to ensure that you're not sharing PII information, and that the data that you're getting back is the proper data type to flow through your system in an automated way. So all of the steps that we have in our toolkit today do a great job for validating and checking and auditing the to and from these models. And in terms of security, we get a lot of questions. Can you send your data to ChatGPT? Is it safe? What should you do? I will mention that the major vendors all offer enterprise security, so things like SOC 2, Type 2, PCI DSS, HIPAA compliance. But depending on who you're using, you'll need to check for yourself. We can't be your lawyer. We don't know exactly what you're doing. So they all offer it, but be careful and do your homework. Okay, now into the vector databases and embeddings portion here, because I think this is key in terms of this use case and many others that I think you all have internally. So a bit about what these language models are doing with text. So here we've got like 3 short sentences. What these embedding models do is they take this sentence and turn it into a vector, which depending on the model and depending on the database can be, in our case, I think it's 1,536 vectors long, right? But some of these models go into the multiple thousands or tens of thousands of vectors. But it creates this vector that's in multidimensional space, right? So if you look at the example below, here's some sentences, and you can see that some of them are close to each other. And this is only 2 positional vectors, right? So what these vector databases are doing is they're using all these multi-dimensions, and it's measuring the distance between things in this multi-dimensional space. So the embedding model takes text, turns it into numbers, which makes it super fast. So the search for these vector databases are very fast. And it's like it's getting the gist of the sentence and getting you a close match. So this is kind of what it's doing behind the scenes. So here's a bit more explanation of what we're about to walk through, right? So there's 2 processes here. On the right-hand side, what we're doing is we're taking company data, and the example that we're going to show you is a field in Salesforce that we have that describes a use case, a particular use case for a customer. Some customers have 1, some customers have 45, but we have some use case data. We've taken that, we've run it through this tokenization processing, and I'll talk about that in a minute. We send it to the AI model. We get these what's called embeddings, and then we save it in a vector database. So it's taking traditional data, vectorizing it, and then saving it in a database. And we have a kind of a batch process that Derek has built to run and take all of that and update this database. So this is creating these embeddings and saving them. On the left-hand side is the search process. So a user, for example, will type in a search. We're going to take that text. It's kind of the same process in reverse. We also pre-process that data, send it to the AI model to tokenize, right, and create an embedding. Then we send it to the vector database to search and find something that's close. In our case, I think we're looking for the 7 closest use cases. that somebody has typed in, and then we return those to the user. So there's one process involved in creating these embeddings and saving them, and then a second process involved in searching those embeddings for something that you're interested in, right? Okay, and what's cool about these vector databases is you can save these vector embeddings and then save metadata along with it, right? And I think this is key to understanding these things. We all have read about these large language models hallucinating things, right? Well, if it's super important that you return the exact data that you're looking for, you can vectorize the data and then also kind of save it as the text, and then return the original text in your return field. And that way you're ensuring that you're not getting this hallucination, and that you're basically using the large language models as a very advanced search algorithm. So that's what this, and this is what Derek has done in the example. He's vectorized the use cases, but he's also saved the actual text, and then a lot of other metadata around it, like who the customer was, things like that. And then finally, jumping back here, this tokenization process, taking the data and vectorizing it, there's some best practices around doing that. So it's putting everything in lowercase, removing punctuations, removing URLs and numbers, and stop words like the, is, and. There's certain words that really don't add much to this vector. And actually in decisions, in a module soon to be launched later this month, we've basically taken all of these and put it in a step to make it easy to do within the decisions platform. So this is coming very soon, but there are what I'll call text pre-processing best case examples, best use case examples for how to pre-process that text. Okay, so that's kind of the background to how this stuff all works and where we think you can get value out of it. And again, our example is finding use cases, but once you start to see this and think about all of the data, textual data that you have living within your company, think about manuals, process manuals, and things that you use within your company that you could expose to your users in a chatbot or in a little app that's specifically designed for a use case. I think you'll start to see all of the possibilities here. Within decisions, to access this OpenAI module, you simply go to the features section, download the module. We have lots of other modules there, so you'll see stuff like Okta, DocuSign, you name it. We have a couple dozens of these. You search for the OpenAI module, you can download it. There's only one thing you need to enter into that module, and that's in this case, it's for the OpenAI key. So if you create an account with OpenAI, you got to put in a credit card. They'll give you a few, I don't know, some number of free tokens to use and play with. And actually, the stuff that Derek will show you shortly, we're talking fractions of a penny, so it's not very expensive to use this. And then once you've got it installed, you'll find a series of steps, and Derek will shortly show you how those are used. You can see there's, I think, 7 of them right now, or 7, 9. There'll be more to come, but they're all within our OpenAI module within Decisions. Now, you have to be on version 8.12 or higher to get it. So one more reason to get current on your Decisions version. Okay, one more slide on data privacy and security. As I mentioned earlier, OpenAI, Google, Microsoft, they all have enterprise versions now. And just for some background, like OpenAI, mentions that they don't retain or use data that has been sent via the API to actually improve the models. It's encrypted to and fro, and users have control over their data. So again, check on your own, but just sharing a bit about what these companies have. All right. There's been kind of a long setup to this, but at this point now, I will turn it over to Derek, and then I'll be providing color commentary from here on out.
Yeah. Well, thank you, Gordon. I really appreciate it. All right, so today we're going to really talk about, what we built inside of Slack. So really kind of talk about the whole use case object. Use cases are essentially describing what our customers are using our software for. So we have a team, a customer service team or success team that's actually collecting this information when they meet with our customers and providing all that information into Salesforce. So we have all the data, we know what our customers are using us for, but we didn't really have a great way of searching these use cases. We kind of went to old ways. Hey, go ahead,
Yeah,
Gordon.
let me jump in here for a minute. So what we used to do is we had this big slide deck, and for every customer, we would create a slide, we type things out. And for sales, we often get asked, have you ever done this? Have you done that? Has anyone used decisions to, right, build a medical app that does care pathways, right? So questions like that. And it's difficult to share that knowledge, but now with what Derek's going to show you, you can just type it in and we can search for similar use cases to talk about.
Yeah, exactly. Thank you. Yeah, so I mean, on top of that too, we've always had the request of people saying, "Hey, we need a better search capabilities to search these use cases," because the old ways they worked, but they didn't work as well. And then when ChatGPT came out, we actually were given those capabilities very easily. So today, what we're going to kind of really highlight is, we're going to show off Slack that's integrating with decisions in OpenAI. So really the process here is you're mentioning a bot. The bot, it will then kind of like respond back and forth. So there's really two pieces to it. The first piece is actually putting this data into the vector database. So as you can see in this diagram, we first extract the data from a source. We cleanse it using decisions and kind of what Gordon was mentioning just a second ago. We then pass that text to OpenAI, which will give us a vector. From there, we store the vector with the metadata into a vector database. We currently use Pinecone for this example. There are other vector databases that you could use, including Postgres, as well as some cloud ones. So a future webinar will actually highlight the Postgres that's internal data only.
Yeah, good point, Derek. The webinar later this month is actually going to use the PostgreSQL vector database.
Yep. So the second piece of this is like once the data is all stored in the vector database, we wanted the ability to communicate and actually query it and get results back really easily. So we have Slack. That's really, where our bot lives. You're interacting in Slack. It will then send that message to decisions where we follow that same cleaning process. We embed it again using OpenAI, and then we do a similarity search through the vector database. So this is finding the closest distance between the text that I inputted and the text that actually exists within the vector database. And then finally, what happens at that point, it will actually respond to Slack. So you never leave Slack. It's very quick, and we're getting ready to demonstrate that to show you how it looks.
All right. And Derek, quick question. How long did this take you to put together what you're about to show us?
Overall, I mean, there was two pieces to it. The whole process end to end was about a week. First was trying to get the data, store it. It took a little bit cleaning, and then we already had an integration with Slack. So that whole process was very smooth and easy to go for.
All righty.
So a couple hours there. All right. Can you see my screen?
Yes.
Very good. All right, so I'm in Slack. This is actually our decision Slack environment. And as you can see, I've had some previous messages before with the bot. So really how this works is, the first thing you need to do is like add the bot. So our bot is called use case, where you then would provide a description that you're trying to search against the vector database. So I'll do the one exactly as above. So a request and approval process. This is kind of a common use case within decisions. We're a workflow tool where you go through a series of steps, which could include a approval process. So by clicking enter, this sends the description to decisions. It goes to OpenAI. OpenAI queries the database and then responds within the thread itself. And here, when I actually look at the response, what we were asking to pull is the top closest matches, the top 8 actually. And what we provide to the end user is the account name. We're currently hiding the name and just showing the URL to protect our customers. The use case name that was actually stored within Salesforce and the description, the industry associated with the account, and how close of a match this was to my original text. So again, it's taking this text, the request and approval process, and comparing how close of a match it was to this description. You can see it's an 88% match, and it's still a very close match. Overall, there's 8 separate use cases that responded, and you can see how each one matches up and how close. So employee to request telework, approval process, employee terminate or employee PTO, employee termination. So all very, very close matches to, the original description that I provided. Like something to mention here, this is only as good as the data that you input it. So the cleaning piece of it, actually having great data on the input side will give you better results on the output. And then again, this is a advanced search that we were not really capable of doing until we were able to get a module like OpenAI. So even like my request is a request and approval process. You can see employee request to telework. It's still very close to that original description. So what we could do, I'll provide a couple of examples and we can kind of go through it. And really how this layout came out was, this is kind of like the Slack integration. When you kind of look into the Slack documentation, it tells you how to format this, and I'll kind of dive into that in a little bit once we get into the decisions workflow. So providing another example, integrations with external systems. By clicking enter, you can see that it responds very quick. There's a lot happening behind the scenes, and for this to be so quick is, pretty amazing. The same thing, we said integrating with external systems. You can see this is a little bit longer of a description, and it still has a pretty high match score. I'll kind of talk about this match score in a little bit. You typically want to set a threshold here, and I'll explain what that means in a second. But you can see there's 8 different use cases that responded. There's links, so I can click this, it'll redirect me to Salesforce if I did so. You can actually see the name, the description, and so forth. I'm going to probably do 2 or 3 more, and then I'm going to actually jump into the workflows to show how this was built. So SAP integration, this is very common. A lot of people have SAP. It's a very, very big tool. So you can see that we have different industries. There's manufacturing, there's business services, insurance, finance. So you can kind of see like all the value this provides, but here's the description. So if I'm on a call with a prospect, essentially I could figure out the problem that they are trying to solve and pass that description into this bot, and it will show me if we've done this similar in the past with other customers of ours.
So Derek, we have a question for you.
Yeah.
Is the similarity search using cosine similarity or Pearson's correlation?
This one's using cosine. So we decided to go with cosine. Cosine's typically the preferred method with similarity search. There's a couple options, and it really depends on the vector database you have. So Pinecone had 3 other two other options outside of cosine, but for this one, yes,
Yeah.
cosine.
All right. Very technical and in the weeds. Um,
Yeah,
then
and
I
then
think there was
yeah,
another question. How do you incorporate numeric data that holds relevance in responding to certain questions?
yeah, it's a good question. It's really dependent on the use case that you're doing the similarity search. For me, when we have these use cases in Salesforce, we wanted to exclude the numerical values. They really present a need for us. In some use cases, you could keep them. And I'll show you, even with the step that Gordon was showing you, you have the ability to select which options you want to remove from the text and which ones you want to keep. So that would be a great example of using that step, unchecking the numerical values. Essentially, how this works is it takes the text, it embeds the text, and then stores it in the database, and then it will search by text. So there's different things you could do to really, get that down correctly. All right, so anything else?
Enough for now.
Okay. The last thing I wanted to show, for this example, right, I'm adding the bot in Slack and I'm saying go async. It's a very vague description. And, when you pass in vague results, it's really hard to get like an accurate response. And something that we noticed after running this for a while is we wanted to set a threshold, like a baseline, where we noticed the results were poor or not as good as, everything above this baseline. In our example, we decided to go with 75%. So this is like the match between this description and the description in the use case. If the match score is below 75%, we don't even want to include it. It's not as accurate as anything above. So we completely filter out those results and we'll actually have the bot respond saying we need a more detailed query. Again, this is very use case dependent, meaning that, sometimes you might want a higher score, something in the above 90s, maybe even 50% for you could work. This is something that you would typically have to look into after you start collecting data. And this has been running for a little bit. So we are able to make those observations. Well, very cool. Yeah, so this is our bot. This is our Slack environment. And, really the next step is showing how this was built. All right, so I'm in our workflow designer, and there was two pieces to this solution. One was actually uploading it to our vector database. Again, we're using a cloud database, vector database called Pinecone. There's other options. We found that this was easy to set up and it worked well for us at the time. So the way this works is you first have to get the data from an external source. We're using Salesforce. This could be, Excel document. It could be Google. There's many different sources that you could choose to do so within decisions. We have integration with Salesforce that's pulling the use case by a query. And essentially we pass a query grabbing, results that have been created or updated over the past week. So this is a scheduled job that runs once a week. It will update the database so we have the most relevant material at that time. Once we get the data, we'll go through each use case. We cleanse the text. We create the embedding using OpenAI. And then finally, we store it in our database. We do have a step coming out shortly within the upcoming month or during our next release that Gordon was describing. In the meantime, I've kind of broken out exactly what we needed to do. Kind of best practices that we learned is lowercase everything, remove punctuation, replace numbers. And again, that's really use case dependent. We didn't need the numbers, so we completely removed them. We strip out URLs, special characters. And when I say white space, if you ever type a paragraph and then you hit enter twice, we want to strip that from this use case because it will affect the results. And then from there, we, like Gordon was mentioned, with the embedding, So OpenAI, we pass in the text. It will spit us out a vector, so a high dimension number. And that's all we really have. And when we go back to update our vector database, we wanted to store metadata with that. And the reason why we do that is faster performance. We don't have to go back and fetch data from that external source that we originally uploaded. It's all directly in that database, and it makes it a lot easier to query and build the message that you saw in Slack. So you can kind of see what this actually looks like going into the database. So the values represents the embedding, and then we have each single item, account ID, category, and so forth.
And again, I think this is a key point in that, it's the metadata that we're returning. So we're not returning something that the large language model, puts together. We're returning the exact description that was typed into Salesforce. Another point I'll share is that the results you saw from Derek's example were very short. Most of our use cases are actually like a paragraph or more of text. Now, in our database, there's a lot of mentions of clients' names. So for the example in the webinar, we used examples that don't show that. So typically, when you're searching, you can type a couple sentences or even a paragraph of the use case. And these models are fantastic at finding use cases that live close to that and returning them.
Yeah, that is correct. All right, so that was actually solution number one. I'm going to jump into another workflow. So this is actually what Slack is calling. So as I mentioned the bot name use case and I typed it in that description and enter, what happens is Slack will call this workflow. I get the JSON response. I use this step to make it a known object. I find the actual description that the person sent. And then we follow that same process. I clean the string by, lowercasing everything, removing the punctuation, numbers, URLs, etc. Create the embedding using OpenAI. So we pass that same text after it's been cleaned. We get the actual vector, and then we query the database, which will find us the closest top X results. So we're able to define how many results we want to return. There's this option top K. For ours, we're doing the top 8 results. And then you could include that metadata that I uploaded. And if you ever need to, you could return the actual embedding. We didn't need to for ours. It's kind of pointless to bring back the embedding, so we just wanted the metadata for this. So after it cleans it, embeds it, it will query the database. Pinecone's doing all the heavy lifting on the similarity search and will return us the results. This is where that baseline comes into play. So we have a rule that looks at the results and says, does any of the match scores, are they less than 75% to the original text? If so, we filter them out. So we have a step in decisions that could do that for us automatically. If there are no matches, that's when we have this type of message response to saying, hey, provide a better query. If not, we are able to build the section. So again, this is how Slack needs the response. You have to build it in a specific format, but you can kind of see an example of like the icons, the use case number, just really I'm building this so I can send it back to Slack to make the message look pretty as such. And then from there, it makes that call back to Slack, and it will actually reply in the thread instead of like responding to the whole channel. So very cool process.
Yeah, and again, so this is like a headless application. So Slack is the UI, and all of this is happening automatically behind the scenes. Answer a couple questions at this point. So one question: which available LLM is being used for training? In this case, it was OpenAI, one of theirs, Derek, I think.
Yeah, we're using so the specific model was the text embedding, the ADA or ADA 002. So as new models come out, our steps will actually have those as well in future releases. There are two options that we had for the actual embedding piece. Depending on the step, there's essentially a separate model associated with it.
And next, later this month, we'll be using some of the Google models, both for embedding and for the model itself. And then was a question about cleaning data processes handled by the decisions environment. That's a yes. And as Derek showed, the sequence of steps, which does all of that lowercase type stuff. Here's another question. Is the interface able to ingest tabular or visual data for training of chatbot? There's an awful lot of models out there. Some of them are good for like image to text. So in this case, we're using, the OpenAI, but depending on what you're doing, if it's tabular data, some of them you can send CSV files to some of these models. And we'll be showing examples of this in the future. I think we have a webinar scheduled in October where we'll be sending it data for analysis. So more to come on that. We did have a question here. How do these virtual agents or chatbots help in business process automation, in which, specific to industry, let's say banking, all repetitive processes, these chatbots can replace human beings? I think the best example of this is we did a webinar one or two back. The title of it was document extraction, but the process that we automated was the receiving of an invoice from a customer and automatically putting it into our financial accounting system. So we have here at Decisions, like many companies, we have an email inbox that we ask all of our clients or suppliers rather to send us their invoices. We get about 150 of those monthly. We now can read that email inbox, extract the PDF, go through the same process, send it to ChatGPT, get the amounts, the vendor, the invoice number, line items, and basically pump all that into our accounting system such that somebody in accounting, it's all there, all entered. They just need to open up the invoice, compare it to what's there, and from there they can decide whether to pay or what needs to happen. So there's a lot of things that can be automated. We did another webinar on data cleanup. So taking unstructured and junky Excel documents, sending it to get cleaned up in a way that can automate data cleanup processes. So this example here is probably it's not an automation example. It's an enhancing the people and making the search, giving them information better, faster.
Yeah. Something else, it could be used as like a recommendation engine as well. Embeddings are very powerful for like recommending things that are similar to what you might be doing.
Okay, there was a question, how do you do the embedding for the search query coming from Slack? And the answer there is it was exactly the same as the way we stored the data. So we have, Derek, you could pull that up again.
Yeah, absolutely. Yeah, so really the process we do is we clean it. Once the actual text has been embedded, so this is the exact same subflow that's being used in the process being uploaded. So going back, this is uploading to the vector database. We have this flow where it's removing the punctuation, white space, numbers, and so forth. So we reuse it. We create the embedding by passing it directly into OpenAI. So we follow the exact same process on the way we upload it to the way we search it so that we can try to get the result as close as possible to that original description.
Okay, and there was a question too here, Derek, about what's the estimated cost of the use case that we're demoing from Decisions and OpenAI?
Yeah, it's a great question. I mean, the embedding piece of it is very, very cheap. To my knowledge, it was 100th of a penny for 1,000 tokens. So what it's doing is taking your text, and your text represents a certain number of tokens. So each word is a token, I believe. So you have to type in 1,000 words to be charged 1,000 or yeah, 1,000th of a penny. So over a long period of time, with people constantly using, we've had this thing running for a couple months now, and I haven't even seen it get over $1.
Yeah, so this piece of it is very cheap.
Yeah, and then depending on which vector database you use, if you use like a cloud database, it could be they charge you per table you have, which Pinecone is roughly like $80 a month. But if you had something internal, such like Postgres, it would be almost free.
Here's another question, Derek. I understand source docs can be almost anything. Can the source data be from a large number of Microsoft Word and Excel docs that include both text, tables, and graphics?
Yeah, it's a great question. I mean, for ChatGPT using these embeddings, it's all text related, but absolutely, you could upload a Word document, you could do Excel document. We can go through each item or each section, embed that and store it in the database. It might be a slightly different process than I've shown today. In regards to images, OpenAI embedding model actually does not have ability to do the image unless you transfer it into something called as a byte array. That might be possible. So you're actually doing the image array versus what the image actually looks like. That might be tricky. I wouldn't trust that 100%. There might be other models out there that would work well for that
Yeah,
specific use case.
and what I'll also say is sit tight because the webinar we're doing next around RFPs is all of that data today lives in Excel. So we're going to show you how we're taking data from Excel, running it through here to create a chatbot for filling out RFPs and security questionnaires. We're a technical product, and throughout the buying process, we get asked tons of technical questions. And there are times you type up a very good answer to a question, and in an RFP, for example, then it sits on a drive somewhere, and you get a new RFP, and you're like, oh, should I go find that answer? How would I find it? This is a way to make that process super fast and efficient. Is taking data that you have somewhere that people have spent a lot of time creating these documents, procedures, answers, and putting in a format that can be very easily accessed. Okay. Again, Derek, we had another question about how long this took to build. Now, I will say Derek is a crackerjack decisions developer and put this together in a week. But that gives you an idea. A week to do this. You can see there was not that many flows here, not that many steps put together. And within our next release of our module, we're going to make it even easier by combining a lot of these steps into one, especially all the pre-processing that goes on with this with the text. Okay, and then there was a question, I guess about, what decisions, what part does decisions play in all of this and what the product does. Again, what I'd recommend is you sign up for uh, a demo, and a sales engineer will walk you through. But the part that decisions plays in this is orchestrating between Slack, between a vector database, and between these large language models. So we're the kind of the orchestrator to take data that we have in Salesforce, to vectorize it and save it in the database. Decisions is doing that work. We sit between Slack and the vector database and the large language model to orchestrate all the back and forth between these various pieces to get all this working.
Yeah, we completely remove the manual process that is being done today of copying and pasting and uploading it to chat GPT online, and then taking those results and doing something with it. We completely orchestrate it, remove the human effort after it has been designed and developed, and it's completely on its own at this point.
Another question, Derek. There was a question about the like the scoring of the closest fit, and where does that come from, and how do we produce that?
Yeah, it's a great question. Within Pinecone asks you the metric you want to do the similarity search. So we chose to do it with cosine. Pinecone is doing all the math behind the scenes where we actually just give it the text. It will find the closest results and it will determine that score. So it's based on what is stored in the database and what I passed in. If I passed in an exact match of the description that it exists in the database, I would get 100% match. If I'm slightly off, that's when the score starts going down and down into a certain baseline. So it's really the database doing a lot of the work behind the scenes. There are other methods you could do. You could build essentially a model that does the similarity search for you. In our use case, we let the database do its thing.
Here's a really good question. How is this technique a significant value add over advanced keyword searches available on intranet document and knowledge source repositories, given such source data may be difficult to duplicate? I'll take a cut at this first, Derek. Having played a lot with this search bot myself, I gave the example before about searching for customers who do use us for medical care pathways, for example. Well, when the use case, if I did a traditional keyword search, the use case within our Salesforce would have had to include those words, right? But what's amazing with this technology is some of our use cases, the way that they've been typed in, they don't use medical care pathways, but what was typed up, it's like doctors use this system to understand how best to care for patients with, oncology, specifically this. So the use case might be typed up, never using those words, but this technology will find that. And whereas, just using a keyword search doesn't find those things. So I think that's like the key in that this type of search finds those things that are a close fit without having to use the exact right words.
Yeah, that's right. I mean, it's plotting two different points within a vector database, and it doesn't matter exactly what the words are, but how close of a match they are. So it could be completely different, but very related, but it does it based on how close they are within the database. It's like a recommendation engine. If you ever go on to Netflix and it says this movie's a 97% match, it's looking at the descriptions of the movies and comparing how close they are, and is recommending it to you when it's completely different, but similar. And it's the same use case here. And so it's something that we can't really do with the naked eye.
Okay, and then somebody asked if they don't use Slack, yes, you could use Decisions for that. Decisions, we have a UI interface, so we could have made this a web-based app that you just go to a page, you type it in on a page, and in fact, I think we'll do that. But if your company uses like Teams or some other chatbot, you can use that, or you can use the Decisions UI to create an interface for an app like this. All right, I think we're just about out of time. Again, I'd highly encourage you to sign up for a demo. You got a kind of a brief overview from Derek with the steps, but one of our sales engineers can walk you through how to build, how quickly you can put together. And again, I think what excites me so much about this technology is the ability to get quick wins, that you can deliver automations quickly, and these models can do things that just wasn't possible in the past, or would have taken an incredible amount of programming versus sending some data and a prompt to one of these models and being able to get back results. So check out our stuff, and we have a couple cool webinars coming up, and we look forward to seeing you next time.
Thank you.
All right. Thanks, everybody.